Hello students, in this class we will see triangles 6.3 last exercise 7 to 9 questions and their solutions. These are based on the last exercise is based on three similarity criteria: AA criteria, SSS criteria, SAS criteria. Okay, we'll see the solutions now. Seventh one we'll see. In the figure 6.38, the altitudes AD and CE of triangle ABC intersect at point P. Show that four set of triangles are similar. Very simple. You have to identify either of three similarity criteria. Basically, in this, especially the seventh, two AA criteria will come for all four questions, sub questions. Okay. We'll say given. What is given? We write AD and CE altitude means AD perpendicular to BC, CE perpendicular to AB. Right? Altitude means they are perpendicular. Okay. Given is that meaning I'm not writing here. This is means ADB 90, ADC also 90, CEA 90, CEB also 90. We can write that, right? See, ADC equal to ADB equal to 90. That is, I'll say, because we are using this in the proof. AEC CEB 90. This part is derived from the first two parts only. Okay. Now to prove, we write all four things what they have given. Triangle AEP similar to triangle CDP. Triangle ABD similar to CBE. Third one I'll write here before only. Triangle AEP similar to triangle ADB. Okay. ADB. ADB. Okay, let me write little here. Okay, I'll write down only. It's not visible. Basically, you copy all four which are to be proved: AEP, ADB, triangle PDC, similar to triangle BEC. Proof. First one. Whatever they've asked, just pick them and say in triangle AEP and triangle CDP. Can you make out similarity criteria? Check out. You visualize only the triangles which we wrote just now. AEP and CDP. We have PVOA, P angle. E is 90, D is 90. So just we are done. By AA criteria, they're similar. So let's see. AEP equal to CDP, which is 90, right? Which is 90, each 90 here. AEP can check out. AEP is nothing but AEC, right? AEC is 90, each 90. Then we have one more common VOA. What is that? APE equal to APE equal to CPD. Why? VOA. We are done by AA criteria. Observe the AP and CDP. P is vertical opposite angle. In AEP, one angle is 90. In CPD, one angle is 90. Just write that. Therefore, we'll just conclude triangle AEP similar to triangle CDP by AA similarity. We'll take the second one. Very simple. All four are like this only. In triangle ABD in triangle ABD and triangle CBE. Just observe the triangles. ABD, where is ABD? ABD here, and CBE. CBE. B is a common angle. ABD and CBE, B is common angle. We read that B common. B equal to B, common angle. Also 190 degree will come. Check out. ABD, we have ADB 90, right? We write that. ADB equal to. In CBE, which is 90? ABD means CEB is 90, right? CEB is 90. CEB 90. They're done. Triangle ABD similar to triangle CBE by AA similarity. Okay. Clear? Third one I'm writing here. Just check out. Same. Pick the triangle AEP and triangle ADB. Whatever they asked us to prove as similar, pick them. Observe the triangle now. AEP and ADB. AEP and ADB, we have A angle common, right? A angle common. AEP and ABD, A is common. Okay? A equal to A, common angle. How do we make out its common? Just extract the figure. We'll understand. I'll draw check out. This is AEP, right? And ABD. Okay, sorry. A is there. ADB we have. P is here only. And we have here E. Right? This is 90. This is 90. So A is common here. AEP we have A common. To ADB A common. Don't take B because AEP doesn't have B. Okay? Thus A is common angle. Write 190 degree angle. What is 90 degree? AEP itself is 90. AEP equal to DAB. AEP equal to DAB. AEP equal to ADB 90 degree. AEP equal to AEP 90. Therefore, triangle AEP similar to triangle ADB by AA similarity. Okay. Only way thing is you have to identify 190 degree, one common angle for all the four. That is the clue and hint here. We pick that fourth one in triangle PDC and triangle BEC. See, observe that PDC and BEC, C angle is common, right? So we write that. Even by looking at the names of the letters, we can make out. C is common angle. Common angle. 90 degree angle you write. PDC, we have PDC itself 90. And BEC, BEC itself 90, right? So you write the 90 degree and say the reason. AA criteria. PDC equal to BEC, that is equal to 90 degree. And conclude they are similar. Therefore, PDC similar to triangle BEC by AA similarity. Hence, or the whole thing only relation the AA criteria. One is 90 degree, one is common angle. Just you have to pick the common angles. That's it. Okay. We'll move to the next question. Eighth one. It is similar but lengthier only. Seventh one. Okay. Let's see the eighth one. E is a point on the side AD produced of a parallelogram ABCD. Means there's no figure. We just draw the figure here. Okay. ABCD. Now read the problem. E is the point on the side AD produced. Means you produce the AD here. It will become AD produced means you produce this to E. Then BE intersects CD at F. BE intersects CD at F means you join B and E. It becomes F here, the intersecting point on CD. Now show that ABE and CFB. See AEB, the whole triangle, CFB are similar. Very simple. How? In AEB and CFB, F is a VOA, right? F is a VOA, we get a VOA. Right? That VOA. Or other way also you can use. In ABE and CFB, C and A are equal because opposite angles of a parallelogram equal property comes. Or we can use, since DC and AB is parallel, ABE is equal to BFC, alternate angle, either way. Okay, let's see. Given, what is given? ABCD is a parallelogram. To prove, what is to be proved? Triangle ABE similar to triangle CFB. Proof. E I'll write little above so that I can use the space for writing. E here. Okay. Proof. Just take in triangle what is to be proved. You take ABE and triangle CFB. Don't get panic here. It is very easy concept in triangles. Only thing you have to you should be able to identify the proper equal angles and apply the similarity criteria. In this two triangle, I'll write all the three applicable. Even you can write two only. I'll write, okay. Oh, D and F will not come because their ABE it will not come. So I can say in ABE this is equal to this because they are alternate angle. So in ABE A equal to CFB C because opposite angles of a parallelogram are equal. A and C are equal. Then we'll take another alternate angle, that is ABE equal to, see ABE means this B angle is equal to the CFB because AB and DC are parallel. Opposite pairs of sides in a parallelogram are parallel, right? Opposite sides. So AEB equal to, you can write ABE and CABE parallel to BCF. BFC or CFB. There is one more parallel angle if you observe that. Because AD and BC are also parallel, I can take AEB and CBF, right? See AEB, see just check out AD, AEB and FBC, right? AEB and AEB and CBF. Alternate. Just you have to observe the angle. See, this is come. This is alternate to this because these are parallel. Similarly, This is alternate. This is E here. This is B here. Okay. This is F here. This is B. Okay. These two and these two. Okay. Therefore, triangle ABE similar to triangle CFB. You can, if you write two angles, you say AA. Otherwise, since I wrote here three angle, I can say AAA similarity. Okay. Please observe the alternate angles only here. One is opposite angle A and C, and two alternate angles. Okay. Hence proved. We conclude that. Yeah. We move to the ninth one. In the figure 6.39, they have given the figure. ABC and AMP are two right angle triangles where M and B are 90 degree there. Prove that those two triangles are similar, and next part is easy, like how we used to do in congruent triangles by CPCT. Here we write by corresponding sides of the similar triangles. Second part is easy. First part will just identify the criteria. Okay, I'll draw the figure here. AP is there. Here I'll make a C, sorry, B here. This is C. I'll join this. I'll make this as 90 degree and this will be 90. This is M, this is A, this is B. So given we write what is given? AMP, two right angle triangles, right? That is AMP is 90. AMP equal to all 90 degree we can write. AMP, PBC, okay, CMP, ABC, whatever. AMP equal to PBC equal to ABC equal to PMC we called? No. PMC equal to 90. See, basically, how I wrote all these four angles means you construct these two angles and these two angles. Don't get confused. These four angles which are marked there are made 90 degree, and you just write in a statement given. Okay, to prove, just copy it from question. These are the four angles. To prove, copy the question. Triangle ABC similar to triangle AMP, and second part CA by PA equal to BC by MP. Proof. First one, just pick in triangle ABC and triangle AMP. Check out ABC, ABC, AMP. We have common angle A. So we write that A equal to A, common angle. And you write 90 degree. What is ABC 90 we have? ABC itself. What is AMP we have 90? AMP itself is equal to 90. Okay. Then we're done. That's it. Very simple. They are testing our observation skills only. These are not tough questions at all. Okay. We just write those two triangles are similar by AA criteria. Therefore, triangle ABC similar to triangle AMP by AA similarity. Done. Second part, don't break head, just write as is and say the reason. Just like CPCT, we are saying corresponding parts of similar triangles. Corresponding parts or sides of similar triangles. Clear? That's it. Then we will see the 10th one. This is very easy only by angle bisector concept it is. When a line bisects an angle, the bisector angles are equal. That concept it is. Okay. In the, sorry, figure is not given. Just read out the question and try to draw the figure. CD and GH are respectively bisectors of ACB, EFG, such that D and H lie on the sides AB and EF of ABC and EFG. How to start drawing the figure? Draw the figure ABC, separate triangle, EFG, separate triangle. Then read, come back to the question. ABC is one triangle, EFG is another triangle. ABC is one triangle, EFG is another triangle. EFG. Come back to the question. CD, first read out for ABC. CD is the angle bisector of ACB, means D will come here. When angle bisector means the angles are equal, the main angles parts. Similarly, D lies on AB, H lies on EF, and GH is a angle bisector H. Okay. By looking at the sentences, it is clubbed mixed sentence. You break up to form a figure. Now, since GH is an angle bisector for EGH or EGF or FGH, the parts of the angles are again equal here. Okay. Now we have to prove the three parts. We'll write. Now start. Given. What is given? CD is the angle bisector of ABC. That is, we'll say CD bisects ACB. Therefore, what we get from that? ACD equal to BCD. Okay. Since angle bisector means parts of the angles are equal. Similarly, HG bisects EGF. That means, therefore, we get similar ways. FGH equal to EGH. The parts are equal. Angle bisector concept. Now, check out what is also given there. Triangles are similar. ABC and EFG are similar. That also you write it. That's very important. When they say ABC and EFG are similar, either we say all the angles are equal because AAA criteria, all the sides are in proportion by SSS criteria. So we say here triangle ABC similar to triangle EFG. This is also given. So to prove, we copy whatever it is asked. CD by GH equal to AC by FG. Second one, DCB similar to triangle HGE, and triangle DCA similar to triangle HGF. We'll see proof. Remember, when they ask to prove multiple parts, no need to go with the first part first, second part second. No. Sometimes we prove in the reverse order also, or whatever comes first will prove. Some things will be derived from the proved the statements. So in this case, especially first one we are not proving, second, third we are proving. From the third we get the first part. Okay. Let's see. How do you prove? For the second part I'm taking. Okay. In triangle DCB and HGE. Very simple. Say, observe the DCB. Where is DCB? DCB and HGE. We know angle C and G are equal because similarity they are given, right? This I'll call it as 1. Okay. Otherwise, I'll call this as 1 and this as 2 and this as 3. In triangle DCB and HGE, we have B is equal to E because from 3. That we'll write it quickly. B equal to E from 3 because they're similar triangles means the angles are equal. What about other condition? C is also equal to G, but bisectors bisectors of C is means I'll take C also equal to G, but I'll do half C equal to half G. Half C I'll take BCD, which is I want this part, BDC triangle part, not ADC triangle part. Half C is how much? I'll say BCD equal to half G is how much? I'll say EGH. Whatever required in the triangle you take. Half C can be ACD also, but that's not required right now. It's required in the next part. Okay. Therefore, two angles are equal. We'll write we are done. DCB equal to HG. Therefore, triangle DCB similar to triangle HGE by AA similarity. Understood? It's basically by angle A criteria we are using, but half of the one angle will be taken accordingly what is required to be proved. We'll take third one. Similar ways I'm proving in triangle DCA and triangle HGE. HGF, not E. HGF, right? HGF. Check out. DCA and HGF. A is equal to F. Okay. Because A equal to F. This is from 3. Why from 3? 3 states, 2 triangles are similar. Now I take same ways DCA, I take half C only, should be equal to G. This is also from 3. Okay. This is from BCD and EHG from 1 and 2. Okay, from you write the word. I missed it. Okay. Half C is what? I'll take why half C? Divide both, multiply both side by half. It will balance the equation. Now half C, I'll take the upper side part triangle, ADC part. That is ACD. I'll take equal to half G. I'll take FGH. ACD equal to FGH. Understand here? Similar ways it's going. Okay. C equal to G. How I? Because from 3 only. And this is from half C. This is not required, I guess. Half C, I'll take ACD. Half G, I'll take FGH. Last time I took the bottom part. So ACD and FGH are similar. Therefore, by AA, therefore triangle DCA similar to triangle HGF by AA similarity. We are done. Coming back to third one. What is asked? Check out. I'm showing here. Please observe. This why we want to prove. See, since we proved this one, CD by GH. See, CD by GH equal to AC by FG. Right? So that's the reason I told in the beginning we are not proving the first now. Now we are proving the first part. We just write what is proved in the third one, like triangle DCA similar to triangle HGF. We just proved, just write that. we proved above. Therefore, what is required? Just write it. CD by GH equal to AC by FG. You write the reason. You write the reason. Corresponding sides of similar triangles. Corresponding sides of similar triangles. Hence proved. Question looks lengthier, but only thing is application of the theorems are very important. Don't just by heart the theorems. Try to solve the more problems so that by looking at the problems, we can say what criteria will apply to make the triangle similar. Okay. Thank you.